For the calculation of external static pressure of HVAC ducting, there are different software and programs available in the market. All these programs and software are based on three basic studies. Number 1, based on Carrier Handbook. Number 2, based on SMACNA standards. Number 3, based on ASHRAE Handbook. And all these software and programs use any one of the two methods. Number 1, duct equivalent length method. Number 2, duct fitting loss coefficient method. I will explain you the basic concept used in these studies and methods. In this part, we will study duct equivalent length method, and in the second part, we will study duct fitting loss coefficient method. To get Excel sheet, charts, tables used in this study, you can contact me on the email address provided at the end of this tutorial. I, Engineer Nasir, welcome you to our channel NC Engineering and Technologies. Friends, if you are new to our channel or still you have not subscribed it, please subscribe to our channel so that we can make more studies and bring more videos for you. In this tutorial, we will study how to calculate the duct external static pressure using duct equivalent length method that is used in Carrier Handbook. It is the simplest method for the calculation of external static pressure, and we will use equal friction method in our study. In this method, we follow the following three steps. Number 1, first we select the longest or critical path of the duct. Number 2, we calculate the total equivalent length of the duct in the longest or critical path, that is straight duct length plus equivalent length for the duct fittings. Number 3, we calculate the duct friction loss. After this, we use the formula for the calculation of external static pressure. External static pressure equal to total duct equivalent length into friction loss rate. To make easy to understand, I will do two sample exercise for the calculation of duct external static pressure by this method. Number 1, using McQuay duct sizer and duct fittings equivalent length tables from Carrier Handbook. Number 2, using friction loss chart and duct fittings equivalent length tables from the Carrier Handbook. We will use this sample drawing for our study. In this drawing, HU01 is supplying 3600 CFM of air inside a room that is distributed through 6 number of diffusers having tag number 1, 2, 3, 4, 5 and 6. First of all, we will select the longest or the critical path of the duct. That is, in our case, will start from the HU and will go up to the last of the diffuser that is having tag number 6. Number 2, we will give the separate tag number to each duct segment and accessories. In this picture you can see we have given the tag number 1 to the fire damper and tag number 2 to the straight duct having a size 28 by 16 inch and length of 1 meter. In the same way, we have given tag number 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Number 3, making the table for all the duct segments and accessories, showing their sizes, CFM and descriptions. I have created this Excel sheet for the calculation of duct external static pressure based on the formulas in Carrier Handbook. First, we will do our study by using the tables and charts in Carrier Handbook, and then we will apply this value in this Excel sheet to calculate the duct equivalent length. As you can see in this table, for the straight duct size of 28 by 16 feet, we have the length of 1 meter. We can convert it in feet, it will be 3.28. For the straight duct size 20 by 16 inch, the length is 8 meter and it will be converted to 26.24 feet. For the straight duct of size 16 by 12 inch, again we have the length 8 meter and it will be equal to 26.24 feet. For the straight duct 16 by 12 inch size, the length is 6 meter and it can be converted into feet, 19.68 feet. For the straight duct of size 10 feet by 12 feet, we have the length 5 meter and we convert it to 16.4 feet. Item number 3, 5 and 9 are transition pieces, and for the calculation of equivalent length for these transition pieces we will use the formula L equal to N into HV into 100 by HF, where L number of velocity heads, L equivalent length for these fittings, HV velocity pressure, HF friction loss per 100 feet in water gauge, where velocity pressure we can calculate by the formula velocity pressure equal to V divided by 4005 square, where velocity is in FPM. Item number 7 is 90-degree elbow, and for the calculation of equivalent length for 90-degree elbow we will use the table 10 from the carrier handbook. As to use the duct friction loss chart, we need to convert the duct dimension into equivalent round duct diameter. So we will select the equivalent round dia for our rectangular duct dimensions. As we have for rectangular sizes, first we will select the round dia for these sizes. For 28 by 16 inch, we will select from this table the round diameter 22.9. For the size of 20 by 16, we will select the round diameter 19.5. For the duct size 16 by 12 inch, we will select the round 15.1, and for the size 12 by 10, we will select the round diameter 11.9. Let us fill this value in the table. For the size of 28 by 16, we have round diameter 22.9. For the size 20 by 16, we have value 19.5. For the size 16 by 12, we have value 15.1, and for the size 10 by 12, we have value 11.9. When we mark the value of the CFM inside the duct, that is in our case is 3600 CFM, and the duct round diameter, that is in our case is 22.9. So, and the point of intersection of these two, when we extend up to the bottom, we found the friction loss rate, that is 0.09, and the velocity inside the duct we can say 1225 FPM. In the same way, when we apply the CFM value 2400 CFM inside the duct of 20 by 16 inch, we can find from the chart velocity 1100 FPM. When we apply the value of CFM inside the duct 16 by 12 inch, that is 1200 CFM, you can see from the chart the velocity will be 950 FPM. Similarly, for the duct size 10 by 12 inch, we have the CFM 600. When we apply this value in the friction loss chart, you can find the value of velocity, it is 600 FPM. For the calculation of n values, number of velocity heads, we will use the table 10 from the carrier handbook. As the area is decreasing, so we will use the case for contraction. Considering a 30-degree angle, the value of n is equal to 1.02. As we have selected the value of velocity and friction loss rate from the friction loss chart, and we have calculated the value of number of velocity heads, that is equal to 1.02 from the table 10. After applying this value in the formula equivalent length equal to n into hv into 100 divided by hf, we can calculate the equivalent length for the transition piece. Now we will calculate the equivalent length for the 90-degree elbow using the table 10 from the carrier handbook. Assuming short radius when elbow, in our case the value of d equal to 16 inch, assuming throat radius equal to 2 inch, then the value of r will be 8 plus 2 inch. Then the rd ratio will be 6.25. Selecting the nearest value in this table, that is 0.75, and assuming number of when 2, then the LD ratio will be equal to 8. As we have the value of d 16 inch, then the value of L will be 8 into 16 equal to 128 inch, and it will be equal to 11 feet. So in this way the equivalent length for the 90-degree elbow will be 11 feet. After applying the calculated and selected values from the chart in the Excel sheet, we can calculate the total equivalent length of the duct, that is in our case is 358.13 linear square feet. For the calculation of external static pressure, we have the formula ESP equal to total duct equivalent length and friction loss rate. We have calculated the value for total duct equivalent length equal to 358 linear feet, and the friction loss rate is 0.09. After applying this value in the formula, we got the result ESP equal to 0.32 inch water gauge. After adding the value of friction through volume damper, fire damper and grills, we will get the result ESP equal to 0.53 inch water gauge. Considering a 15% safety factor, then we got the result of ESP equal to 0.6 inch water gauge. Now we'll do our exercise with the help of McQuay duct calculator. As for the calculation of equivalent length for a transition piece, we need to calculate the velocity, pressure, friction loss rate and velocity in FPM. We will calculate all these things using McQuay duct calculator. I have created this Excel sheet for the calculation of duct external static pressure. Some values in this table we already know and we have updated in this table. The description we can get from the drawing and we already updated. Duct size also we can get from the drawing and we already updated. The length of the straight duct also we can get from the drawing and we already updated. The equivalent length for the transition piece and elbow we need to calculate. For the calculation of equivalent length for the transition piece, we need to calculate the air velocity in FPM, velocity pressure, number of velocity head. We will calculate now with the help of McQuay duct calculator. We have 4 rectangular duct sizes and we know the CFM flowing through this duct. With the help of this information and using this calculator, we will calculate the air velocity in FPM and velocity pressure. We will start first with 3600 CFM and the duct size 28 by 16 inch. You can see the value of head loss equal to 0.091 and the fluid velocity is 1256.9 and the velocity pressure equal to 0.0985. After applying this value in this Excel sheet, we calculated the equivalent length of this transition piece, which is equal to 110.4 linear feet. Then we will make calculation with 2400 CFM with a duct size 20 by 16 inch. And as we are making this calculation, assuming the equal friction method, so we will follow the same friction loss, but the fluid velocity will change. It is now 1154.3 and the velocity pressure is 0.083 water gauge. After applying this value in this Excel sheet, we have calculated the equivalent length for this duct transition piece, which is equal to 93.03 linear feet. Now we'll make calculation for another transition piece having CFM 1200 with the duct size 16 by 12 inch. From here you can see the fluid velocity 963.9 feet per minute and the velocity pressure is 0.0579. After applying these values in this Excel sheet, we have calculated the equivalent length for this transition piece, which is equal to 64.89 linear feet. Now we will calculate the equivalent length for the 90-degree elbow using the table 10 from the carrier handbook. Assuming short radius when elbow, in our case the value of D equal to 16 inch. Assuming throat radius equal to 2 inch, then the value of R will be 8 plus 2 inch. Then the RD ratio will be 6.25. Selecting the nearest value in this table, that is 0.75, and assuming number of vent 2, then the LD ratio will be equal to 8. As we have the value of D 16 inch, then the value of L will be 8 into 16 equal to 128 inch, and it will be equal to 11 feet. So in this way the equivalent length for the 90-degree elbow will be 11 feet. As we have already calculated the equivalent length for 90-degree elbow, which is 11 feet, now the total equivalent length for all the duct calculated by this Excel sheet is 371.17 linear feet. As we know the formula for the calculation of duct external static pressure, ESP equal to total duct equivalent length into friction loss rate. As we have calculated the total duct equivalent length equal to 371 feet and the friction loss rate is 0.091. After applying this value in this formula, we got the ESP equal to 0.34 water gauge. After adding the friction loss in fire damper, volume damper and diffuser, the total external static pressure is 0.55 inch water gauge. Considering 15% safety factor, so we can get the external static pressure value equal to 0.63 inch water gauge. Excel sheets used in this calculation is created by me based on the concept in ASHRAE, SMACNA and Carrier handbooks. To get these Excel sheets, charts and tables used in this calculation, you can contact me on efga87811@gmail.com.